Good morning all. So in today's class we will see how to find the general solution when you have equal roots for your characteristic equation. So let us see problems today. So the first question is you need to solve for the system dx by dt equal to the matrix is 5 4 then minus 1 1 x. So first we will find out the characteristic equation. So characteristic equation is given by determinant of a minus lambda I equal to 0. So upon solving you will get the equation in the form lambda square minus 6 lambda plus 9 equal to 0. So therefore the roots will be 3 3. So the roots are real and equal. Now since you have only a single root, so let us find the characteristic equation corresponding to the root 3. So when lambda is 3, so the characteristic vector is a vector x such that it satisfies the condition ax equal to 3x. So therefore the vector is given by, so you will get the equation. So here subtract 3 from here, so you will get 2 4 then minus 1 minus 2 varum. So 2 4 minus 1 minus 2x will be equal to 0. So upon row reduction you can see that one row is a multiple of the other. അപ്പോൾ നമുക്ക് second row മൊത്തം 0 ആയിട്ട് എടുക്കാം, and the first row this will be equivalent to 1 2. So you will get the matrix in the form 1 2 0 0 x equal to 0. So that will give the equation x1 plus 2x2 equal to 0. So let me put x2 equal to t, that will give me x1 equal to minus 2t. So therefore the eigenvector is multiple of the vector minus 2 1. So therefore the eigenvector alpha will be equal to minus 2 1. So that is the eigenvector we have. We have seen in the theory that so if you have got one eigenvector corresponding to the equal root lambda, then the second linearly independent solution will be of the form alpha t plus beta into e raised to lambda t, where beta is a vector such that it satisfies a condition. So a minus lambda I into beta must be equal to alpha. So here let me take beta equal to the vector beta 1 beta 2, and now we need to solve for this non-homogeneous system. So we are going to get a non-homogeneous system. അപ്പോൾ നമ്മൾ ഈ സിസ്റ്റം എഴുതാൻ ഇനി, so we know the value of alpha, so you will get 2 4 beta 1 then minus 1 2 beta 2. Okay, then the right hand side you have minus 2 1. So the first equation becomes 2 beta 1 plus 4 beta 2, that will be equal to minus 2, and minus beta 1 minus 2 beta 2 will be equal to 1. So again you can see that the equations are multiples of one another, so the same equation is repeating. So I can so take one of those equations because both the equations are same. So the equation becomes beta 1 plus 2 beta 2 equal to minus 1. Now our aim is to find the value of beta 1 beta 2. So this system will have infinitely many solutions. അപ്പോൾ ഏതെങ്കിലും ഒരു സൊല്യൂഷൻ കണ്ടുപിടിക്കുക such that it satisfies the equation. So I can take beta 1 equal to minus 1 and beta 2 equal to 0. So this will be a solution for the given equation. So we have got the value of beta. അപ്പോൾ നമുക്ക് ഇഷ്ടമുള്ള സൊല്യൂഷൻ നമുക്ക് എടുക്കാം, അതിനനുസരിച്ച് ജനറൽ സൊല്യൂഷനിൽ വ്യത്യാസം ഉണ്ടാവും. സോ ബീറ്റ വിൽ ബി ഈക്വൽ ടു minus 1 0. Now we can write the second solution. So second solution will be x equal to alpha t plus beta into e raised to lambda t. So alpha was the vector minus 2 1 t, mean beta minus 1 0 varum into e raised to lambda t, lambda is 3. So when you add this you will get minus 2t minus 1, then the second component is t into e raised to 3t. Now we have got the two solutions. So So take the linear combination of both the solutions. So therefore the general solution is given by x equal to c1 alpha e raised to lambda t plus c2 this alpha t plus beta e raised to 3t. So taking both the components, so you will get the value of x1 as minus 2c1 e raised to 3t plus c2 minus 2t minus 1 e raised to 3t, and x2 is c1 e raised to 3t plus c2 t e raised to 3t. So that is the general solution. Now let us see one more question. So we need to solve for the equation dx by dt equal to 1 minus 2, 2 minus 3 x. So the first step is to find the characteristic values. So for that take determinant a minus lambda equal to 0. So we will get determinant 1 minus lambda minus 2, then 2 minus 3 minus lambda equal to 0. So upon taking the determinant, we will get the equation lambda square plus 2 lambda plus 1 equal to 0. So the roots will be, so this is lambda plus 1 whole square equal to 0. So roots will be minus 1 minus 1. So therefore the roots are real and equal. So let us find the corresponding eigenvector corresponding to minus 1. So when lambda is minus 1, so we will get the characteristic vector is given by the equation. So we will have a plus I x equal to 0. So the matrix a plus I will be, so you will get 2 varum, 2 minus 2, then 2, then here you will have minus 3 plus 1. Okay. So that is 2 minus 2, 2 minus 2 x equal to 0. The rows are the same. So it will be equivalent to 1 minus 1 0 0. So we can write the equation as x1 minus x2 equal to 0. So let me substitute x2 equal to 2 t. So that will give x1 equal to t. So therefore the eigenvector is tt. So it's a multiple of the vector 1 1. So the corresponding eigenvector is alpha equal to 1 1. So that gives a first solution as alpha e raised to lambda t. So that will be 1 1 e raised to t. Now let us find the second solution. So the second solution will be of the form alpha t plus beta e raised to lambda t. So alpha is 1 1. Now for finding beta, beta will be the solution of the equation a minus lambda I beta equal to alpha. So we know a, lambda and alpha. So using this we need to solve for the value of beta. So let us take beta to be the vector beta 1 beta 2. So when you write the system you will get in the form 2 minus 2, 2 minus 2 beta 1 beta 2 1 1. So the same equation will be the equations will be same, both the equations. So we will get the equation 2 beta 1 minus 2 beta 2 equal to 1. Again the system has infinitely many, this equation has infinitely many solutions. So find any one of the solution. So let me put beta 1 equal to 1 by 2 and beta 2 equal to 0. So we will get a value for beta. So that is 1 by 2 0. So now we can write our second solution. So second solution will be 1 1 t plus 1 by 2 0 e raised to t. So that is t plus 1 by 2 t e raised to t. So now combining both, taking the linear combination, so we can obtain the general solution. So general solution is x equal to c1 e raised to t 1 1 plus c2 e raised to t plus 1 by 2 t. So we can write the solution component wise. So the first component x1 will be c1 e raised to t plus c2 e raised to t into t plus 1 by 2. Then the second component is c1 e raised to t plus c2 t e raised to t. So this is the general solution corresponding to your linear system. So with this I think we have come to the end of first module. So first module we have mainly seen a few theories regarding the solution of the system of linear equation and two different approaches of solving linear system of equations.